We're going to talk about one of the modules that is one of the most useful for numerical analysis in Python, and that's NumPy, which stands for Numerical Python. What this module provides is a lot of calculations that are relevant to matrix analysis or numerical computations. And one of the advantages of this module is that it allows Python to work a lot faster because the main object, the NumPy array, is basically a very lean object that doesn't contain much of the attributes and added objects that other data structures contain. Let me give a few examples on that so that it is easier to understand. Let's say we have an object X, and that object is a list. Let's say we have one, let's say 4, 2, 5, let's say 3. Now what we can see is that this type of data structure contains a lot of added objects, and we can see that with the dir function here. So it contains a lot of methods, it contains a lot of attributes in there, and one of the things that makes lists a lot more loaded is that each of these objects can be of its own type. In other words, right here I have the first object to be an integer and all of the objects to be an integer. But if I want to construct another object here and I want to have the first object to be an integer but the second object to be a string, let's say hello, the third object to be a Boolean value, the fourth object to be, let's say, a tuple that contains let's say certain values in there. So all of that adds to the to what the object is holding inside, because it has to contain also the methods that are attached to each, the methods and attributes that are attached to each of these objects individually. Now, the advantage of using a NumPy array, on the other hand, is, let's say I want to create my array 1, is that all of these objects in a NumPy array are saved more efficiently, and all of them are converted to the same type, so that it is more computational efficient. Now, the convention for this module is to import it using the alias np. So if I do import NumPy as np, then the alias basically holds or retrieves all of the attributes and methods that come with this. So the array method is the one that we are going to cover first. Let's say I want to create array 1, and I would do np array, and inside I can pass actually either a list or a tuple. So let's say that I want to pass this list x1, so I can do this, and basically what that does, let's see if the creation is correct. So I can see that now I created this object to be an array. So again, let me take a look at type of R1, and we can see that this is a NumPy array. And let's just print it to see a few things. Now, we can ideally, for numerical computation, and this is what this sort of warning is telling you, we want to be able to have an array that contains only the same type of object, so that it reduces the computational complexities of what the array is holding on the background. So generally we want to place arrays that are either all numeric or are the same type. So let me start giving some examples of those arrays. Let's create, for example, say create array number 2. And in that array, I want to create all values, let's say, that are floats. Let's say 2.1, let's say 1.0, let's say 3.0. We can see that I didn't create the list first, I just passed it right there. And we can see that the array was created with the float values. The type of this array is a NumPy and the array. I can also create an array and specifically set the types that I would like to have. So for example, I want to create an array here, and let's suppose that the values are for this array 1, 2, 3, and 4, but I want to set the types to, let's say, float. I can use the dtype parameter to change, or to at least set the type to, let's say, float. And if I see array number 3, now all of the values are set to float. So I can use the dtype in the array function to just create the correct type. Now, the main advantage of NumPy is that we are able to create multi-dimensional arrays. What we have created so far are just vectors. And vectors are, again, we can see that these values right here are just 4 values, and they are considered to be just, let's say, a vector. For a multi-dimensional array, we're looking at more dimensions than just one. So, for example, a matrix on the other hand, can be if I take a look at the shape of the array number, let's say 2, I can see that this is a 4-dimensional object. But if I want to create a multi-dimensional array like a matrix, let's say I can create matrix 1 by first creating a list of lists. That's the most common convention. So I want to create lists within a list. So for example, what that means is that I want to create the first row of the matrix in a list. And then I'll separate every row with a comma. So I can do 3, 4, 5. And then I can create the next line to be the next 6, 7, 8. So each one of these rows of the matrix is separated by a comma. And the 3 rows of the matrix are also within a list. So that's important to take care of how many brackets are open or closed. So this, if I see matrix 1, I can see that this is a higher dimensional object. So I can see matrix 1, the shape of this object. Let's say here, let's see. Oops, this should have been created with an NP array. Right, so let me just come back to it. So again, what I had created was just a list, but now you can see that this is a matrix that is based on a NumPy array and is a 3 by 3 matrix. We can create higher dimensional objects like tensors. In tensors, I mean, this also is considered to be a tensor. Tensor is just multi-dimensional array, whether it's a matrix, but tensors can have a shape that contains more than rows and columns. So for example, if I have, let's say, an object that contains this here, let's say it contains one matrix here, so we can see that the rows of the matrix are separated by comma, and they are enclosed within a list. Then I have a second matrix and a third matrix. So I can put all of this together, and now the shape of these NumPy arrays at 3 by 3 by 3. So this is again a higher dimensional tensor. These are very useful for computer vision, where you have different channels of pictures. So again, very interesting to use. Another aspect of NumPy that is really useful is generating data with NumPy. And generating all sorts of data is very simple with the given methods that NumPy actually has. So for example, let me create an object x4, and I can go to the random module, which is a module within NumPy, and from there you can see all of the choices to generate data. So for example, I want to create, let's say, random integers, and let's say I want to create 10 random integers, and I want the size of the matrix or the vectors that are created. Let's say I want to create a 3 by 4 by 5 tensor, and I can see that we created the again, the value here is just the maximum value for the integer that is created, and you can see that this tensor was created with 3 different matrices. Okay, so I can generate all sorts of data. There's one really useful that is the zeros function. It's not within the random module, but that basically generates zeros values, and it's gonna be very useful. You can pass the number of zeros created, or if you want to pass something like let's say an array that is a 3 by 5 array of, let's say, zeros, then you can see that this is a 3 row by 5 column matrix, and you can generate zeros that way. Also, other functions that are useful are the NP1s, which behaves similar to the zeros, but basically creates ones in there. You can use a specific constants, like let's say a 3 by 5, but I just want to have all of them have the value 3.14. Not that we couldn't do that with the NP1s by just multiplying 3.14 times this one, but that might be useful to use in other ways. There are normal values. Again, if you take a look more at the random module, you can see a lot of the distributions that you can have, and the normal distribution is pretty useful to generate values from, but RAND-N, which is standard random normals, but those are the most important to generate data from. Okay, the next thing that I'd like to cover is a few attributes that arrays have that are very useful, and we have seen already. Let's say we created x4, that object right there, we can see that it's a tensor, and it's a 4. Again, we can use the shape attribute, and that's going to be very useful to just know what's the shape of the dimensional object that we're looking at. There are other things to other attributes. If you want to take a look more, you can use the dir function, and you can see all of these values right here are useful. For example, if you want to get the transpose of a given matrix, if you want to get some other values. For example, let's say we take a look at the size. So if I do x4 and the size attribute, what this might just mean is just the number of objects that are within the number of values that are within the NumPy object. So again, it's important to just take a look at this. It's not expected of us to know all of this, but at least there are some of them that could be very helpful. Um, Indexing in terms of NumPy arrays is important to know. And one thing to, let's say, let me create another example. Let's say x1, and I'm going to generate from the rand int. And you can see that, let's say we have the low value, the maximum value, let's say 10, and let's do size equal to, let's say 6. Okay, so in other words, what I have here is just 6 values in an array. Again, I can take a look at the shape. That's going to be 6. Again, that's a one-dimensional array. So I can retrieve the first value by using indexing, as I would do in a list or a tuple. So, and again, that's very useful to get indices. One important thing to note is that in matrices, let's suppose I create this, and now let's put the size. In the size, we can use a tuple here. So let's say a 3x2 matrix. So I can see this matrix here. I can retrieve the first row and let's say second column. So first row, second column by using double indices. So first one would represent the rows, the second one would represent the columns. So I can retrieve, let's say, the first row and the second column by using 0 and 1. Again, remember the indices start at 0. You can use slicing. There are many other useful aspects of NumPy that we will be covering as we go along.